We're solving problem 25 from the 2021 AMC 12N. Let D of n denote the number of positive integers that divide n, including 1 and n. For example, D1 is 1, D2 is 2, and D12 is 6. This function is known as the divisor function. Let f of n be equal to dn divided by the cube root of n. There is a unique positive integer n such that f of capital N is greater than f of lowercase n for all positive integers n is not equal to n. What is the sum of the digits of n? So in the end, basically, if there's a big number, you can factorize it into primes, right? That's called prime factorization. So basically, what you can do is you can plug in prime factors or prime exponents. So like 2, 3, 5, 7, 11, it goes on. And then once you have all the greatest numbers, you multiply them together and sum it up for n. So, and since there is an infinite sequence of recurring prime integers, this has got to stop at some point. So either it decreases or there is a continuity error at some point. Let's just try powers of 2. F of 2, well, this is denominator is 2 factors and then the cube root of 2. For f of 4, we have 3 divided by the cube root of 4. For 8, we have 4 divided by the cube root of 8 is 2. That's simply 2. For 16, however, we have 5 in the denominator and the cube root of 16 in the denominator. We observe that, well, this is less than 2. So this is what's happening. After a set number of terms, the values of the lowercase n start decreasing. So we want the greatest values for each prime factor in this case. So any number, any power of 2 that is 16 or greater is out of the picture. So the one we want is 8 for the powers of 2, 8 or 2 to the power of 3. Let's consider powers of 3. F of 3 is simply 2 over the cube root of 3. F of 9 is equal to 3 over cube root of 9. And f of 27 is, this is 4 over the cube root of 27, which is 3. And we notice here again that, well, we see that 3 over the cube root of 9 is greater than 4/3. So if we have this, then that means any values of 27 in powers of 3, 27 or higher makes the whole thing decrease. So we don't want any value higher than that or equal to 27. So therefore our power of 3 is 3 squared or 9. If we go on with powers of 5, let's just erase this. Powers of 5, f of 5 is equal to 2 over 5, the cube root of 5. F of 25 is equal to 3 over the cube root of 25. We see that that f of 5 is greater than f of 25. So this value and any of those after it, powers of 5, will not work because that's going to decrease the value. So our power of 5 is just 5. Now let's consider sevens. f of 7, well, you can do this on your own, just plug in the same thing, and you find that f of 7 is greater than f of 49, and this is a trend that continues on to f of 11, when f of 11 is less than 1, and that will decrease our total value. So, therefore, our value for 7 is just 7. So now that we have all these prime factors, we can multiply them together. 2 cubed times 3 squared times 5 times 7 is going to be 2,520. So the sum of the digits in this number is 2 plus 5 plus 2 is equal to 9, our answer for this problem.